Okay, this should be a refresher because this is not the first time that we've dealt with shading or inequalities. So if you don't remember, then make sure you listen in through the whole video. If you do remember, then, if you don't remember, please take a listen. So the first part, I am simply going to write out a lot of information. So there isn't going to be much talking, and then we're going to solve the first example here. So, first and foremost, we're going to solve for y. We're going to do that by moving x to the other side. And then we're going to divide by y's coefficient. Okay, next we will graph using the y-intercept do recall that that is a coordinate 0, b. And we're also going to use the slope. Recall the slope, that is your m, or sometimes you guys say that's rise over run. Remember, you go up if it's positive, down if it's negative, and always to the right, because you want the denominator to also be positive. Okay. This we've talked about before. Inclusive are solid lines, and exclusive, they are dashed lines. All right, so whenever you shade, you're going to shade according to the inequality. And you're going to refer back to your B. Okay, now, this one is important because this is probably something that you do not recall, and, well, we don't have that much time to review over it. So, remember, if you have y equals as an equation, so let's say y equals 2, or y equals -5, it doesn't matter. If y is equal to some number, that is going to create a horizontal line, okay? So whenever you have a line that is horizontal, that means that your slope is 0. Now the thing is that it will also be the case if you have an equation or if you have an inequality, which are these symbols that we're going to be going over again, okay? That one there. Any of those inequality symbols. Oh gosh, that's a little messy. Here we go. All right, now, in comparison, if you have a line that begins with x equals, that's going to be the exact opposite. So if you have x equals some number, some constant, the opposite would be vertical. Remember, that means up and down. So whenever you have a vertical line in comparison, we would say that our m, our slope, is undefined. All right? This is something that we would refer to the acronym HOY, H0Y, horizontal, zero slope, y equals, VUX, vertical, undefined slope, x equals. All right? Okay. Now let's go ahead and zoom out just a bit. There we go, and fill these out. So, solid lines, we would call those, just like we set up here. Yeah. Inclusive. So, the symbols that you have that are inclusive would be a greater than or equal to, a less than or equal to, and obviously equal to. In comparison, the opposite we have would be, don't know where my orange pen is. Exclusive. All right. So our exclusive symbols do not have the equal sign with it. So that would be something like the greater than symbol or the less than symbol. All right. Now, shading. That one people tend to forget. So, you will shade above if it is a greater than. So that would be something like greater than, or, there we go, greater than or equal to. In comparison, you would shade below if you have any of the less thans. So that would be less than or equal to. All right. Now, let's go ahead and start on our example here. Do notice that this equation, or sorry, inequality is in a linear standard form. Now, whenever you have this standard form, it's a little bit more difficult to graph it. So what I'd like to do is convert it into slope-intercept form, because then I have a y-intercept, I have a slope I can follow, it's a lot easier. So to solve for y, I'm going to move x to the other side. Using the inverse operation, I'm going to eliminate the 2x and bring down negative 3y is less than, just for now, I'm going to go ahead and keep it exactly what it looks like, 12 minus 2x. Okay. And then, obviously, divide by y's coefficient, which is negative 3. Now, remember, whenever you divide, you're going to divide everything across the board. Although, something interesting happens here. Obviously, this over here would reduce to 1. But do take note, I'm going to write this in red here. When dividing or multiplying, an inequality, by a negative, the inequality sign flips. This one's a little bit bigger. All right, so since I divided by a negative here, this symbol will flip to become, so now I'm going to have, instead of y is less than, literally I take this symbol and just flip it over. So it's not going to change whether it's inclusive or exclusive, it's going to change it from a less than symbol to a greater than symbol. I think I'll put that one in the, here we go. Then that would be -4. Negative divided by negative would be positive 2 over 3x. So if you wanted here, you could rewrite it. I'm a little lazy, so I'm just going to go ahead and label over here. I have my, oh man, I guess I should put that a different color. I have my y-intercept, which would be a coordinate 0, comma, -4. And I also have my slope, m, would be 2 over 3. That's a +2 and a +3. So, graphing this should be fairly easy. 0, -3. And now I'm going to go up 2 to the right 3 until I've run out of space, and then I'm going to go backwards down 2 to the left 3. Now, because we have an exclusive symbol here, we're going to create a dashed line. And the easiest way is just write small dashes on those dots. And please do not forget your arrows that should go all the way across. Now, it is a greater than symbol, so that means I will be shading above. Now, for those of you who get a little confused as to which side is above or below, usually what I do is I'll ask, what number is greater than -4? -3 is greater. -2, 1, 4, all these numbers are greater than -4, so that would lead me to color the top portion. Before I flip this over, this is going to be page 14, so go ahead and label it below. Now, oh, this is a little dark, so hopefully you'll be able to decipher these numbers here. There we go. First and foremost, let's go ahead and identify our y-intercept, which would be, so here, let's darken up my x-axis and maybe label that, and my y-axis right there. That should help out. Okay, so now that we can see that a little bit better, our y-intercept is right here. So we would write parenthesis 0, comma, that would be 1, 2, negative 3. Now, whenever you're trying to find slope, this is hard for most people, especially if you have, well, not so good vision. So, as I'm taking a look, I notice that my x-intercept is in between 2 points here, 2 whole numbers. So that one wouldn't be good. But I do see right here looks as if it is a coordinate. So that looks like I went up 1, 2, 3, 4 over 2. Okay, so that means if I go 4 divided by 2, that would be reduced to up 1, 2 over 1. Okay, yeah, I definitely see that. So if I went up 2 and to the right 1, that would mean that my slope is a 2. All right. Now, if this were just a regular line and I asked you to write out the slope-intercept form, y equals mx plus b, that one should be fairly simple. I would write y is equal to my slope of 2 x, and then my b is actually negative 3. Okay, but this is an inequality, so did we shade above or below the line? So, because I shaded below, that would mean I would use either of these 2 less than symbols. So I'm just going to fill in those 2 symbols here. Now, we do have here, what kind of line? A dashed line. So, because it's dashed, I would have to choose the less than symbol. So putting that all together, my inequality would actually be y is less than 2x minus 3. Now this was just a summary of how to graph standard form inequalities. What we will be doing, because this is Algebra 1 level, the Algebra 2 level, we will be taking not just one of these, but 2 of them, all right? And that's what we'll be going over in class.